Bill Nye the Science.
Brought to you by Electron Diffraction. One electron at a time. I thought it was a wave. Is it a wave? I don't know.
Hello, Angie.
Hi, Dr. Arteaga.
Nice to meet you.
Nice to
How are
meet
you doing today?
Good, thank you.
Well, as an incoming graduate student, there's a couple things you should know. Specifically, the double slit experiment.
All right.
Well, as you can see here on the board, we would suppose you have one slit, you get one line, correct?
Correct.
You have two slits, you would assume you would get two lines out, correct?
Right.
However, why don't we test this out to see if it actually works that way? So the double slit experiment was created by Thomas Young in the 1800s in order to explain the properties of light acting as both particles and a wave. So we already know you have a single slit, you should see a single line. If you have two slits, you suppose you see two lines. However, using our laser and our multi-split apparatus, we could see, as you can see here, that we actually are getting more than just two lines.
What? I thought we were supposed to see two lines.
Well, you see, Angie, that's what I want to explain to you.
To understand the topic of electron diffraction, we have to go way back to the days of Sir Isaac Newton. In the late 1600s, Sir Isaac Newton proposed that light was composed of a stream of particles called corpuscles. Basically, small discrete particles. At the same time, physicist Christian Huygens came up with a different theory. He came up with the theory that light is composed of waves, not particles. This sparked the debate for the ages. Alright. Maybe not for the ages, but it was settled by another physicist named Thomas Young. His double-slit experiment brought out the idea of the wave-particle duality, which determined that light actually contained both the properties of both particles and waves.
So how can light have both properties of a particle and a wave? Back in time, Einstein introduced the concept of photons, stating that light was composed of particles, which are concentrations of energy incorporated into a wave. With this, de Broglie stated that a particle of matter that contains a mass m and a velocity v would have to be associated with a wave.
We were talking about electron diffraction.
Don't you see, we are talking about electron diffraction. The electron is a particle of matter that has the same diffraction pattern.
What an awesome experiment.
Yeah.
So what do you think is happening?
I'm not really sure.
That's perfectly fine. So to explain how electrons behave as light, let's picture two situations. We shine light through a slit, and what do we get? One line, right? Yeah, and then we suppose that we would shine light to two slits, and we would get two lines. But as you saw, that's not what we're getting. Instead, we're getting a diffraction pattern, and that's because the electrons are behaving as both particles and a wave. So when our light is passing through two slits, what is actually happening is that the waves are causing constructive and destructive interference, which is causing this awesome diffraction pattern. Isn't it great?
Yeah.
Super cool!